Welcome to Unit 4, Trigonometry. The word trigonometry actually means triangle measure. So we're going to be looking at the measurements of angles and sides of triangles. Topic 1 is trigonometric ratios, which will look at fractions created by trigonometry. So the idea of trigonometry is that we're going to look at the relationship between sides and angles of triangles. So if I have a triangle that kind of looks like this is angle B, this is angle A, angle B, angle C. Then across from it is side A, across from B is side B, and across from it is side C. So I have angles, angle A, angle B, and angle C. And I have sides, little a, little b, little c, or side A is BC, side B is AC, and side C is AB. And trigonometry is all over the place. From physics class, you may recognize it from sound and light waves, tides, and many other applications all around the world. So for right now, when we do trigonometry, we're always going to look at a right triangle, and we're going to look from angle A's perspective. This is angle A right here. This side is always the hypotenuse because it is the longest side, and it's across from the right angle. This side here is the opposite side because it is across from angle A, and this side here is adjacent because it is next to angle A. So we're always going to deal with these three sides in our triangle: the opposite side, the adjacent side, and the hypotenuse. And the hypotenuse is always the same, always across from the 90-degree angle. So for my picture here, here's my angle. This is hypotenuse, always along a side. Now you're going to ask about this letter here. This little here is called theta. It is a Greek letter that is used many times to represent angles. So across from angle theta is the opposite side. And then at the bottom here, this is the adjacent side because it is next to the angle theta that we're looking at. So I always need a point of reference. So when I look at angle B is right here, and opposite would be across, that is side B. The hypotenuse is always the same. It's always across, it's always along a side, across from the 90-degree angle, so that is side C. Then it says angle A. Well, right here is angle A, and adjacent to it is side B because it's next to it. And then again, angle A. What's opposite of it or across from it is side A. And then finally, angle B adjacent to it. Well, adjacent means the word next to, so that is side A. And if we look very carefully, we have a nice relationship where these two go together and these two go together. So what are we trying to look at? We're trying to look at these trigonometric ratios. And I'm not going to say the word trigonometric too often. I'm going to say the word trig, which is short for that. And it's a ratio of the lengths between two sides in a right triangle. I always need a point of reference. And we have three main trig functions, and they're called sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated TAN. And these keys are on your calculator. I'll show you where they're at in a minute. And sine of an angle is always equal to the opposite side over the hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. And tangent of an angle is equal to the opposite side over the adjacent side. Okay, and this is what we're going to be working on for not just for today, but for this whole unit. So when I look at angle A is right here. Across from it is the opposite side. Next to it is the adjacent side. And side C is always the hypotenuse based on it's across with a 90-degree angle. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. If I use the letters given to me, sine of angle A is A over C, cosine of angle A is B over C, and tangent of angle A is A over B. This relationship will change slightly when I look at angle B as my reference. So now makes side B the opposite side, makes side A the adjacent side, and C remains the hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And I put my letters in here. I get opposite is going to be B over C. Adjacent is going to be A over C. And tangent is going to be B over A. And you notice that these changed for angle B compared to angle A because I had to use different sides for opposite and adjacent. So is there an easy way to remember all this? And there is. And it's called SOHCAHTOA. I'm using the letters S, C, and T to represent sine, cosine, and tangent. The letters O for opposite, H for hypotenuse, and A for adjacent. And we'll set this all up. And choose a different color. So sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. And tangent of an angle is equal to opposite over adjacent, or if you pay really close attention, S is O over H, so C is A over H, ka, and T is O over A, toa. Sine, cosine, tangent, SOHCAHTOA. So tangent of Z, here's my angle Z here. I need to know, let's see, tangent is opposite over adjacent, so I need to know the opposite side. I need to know the adjacent side. So I get 21 over 28, and I reduce it, and I get 3/4. So now when I do angle C is right here. I need to know adjacent and the hypotenuse, because it is adjacent over hypotenuse, and I get 16 over 34, and when I reduce that, I get 8 over 17. Do not forget to reduce fractions. It is necessary to reduce fractions in my class. So next we're going to see how sine and cosine for different sized triangles won't matter if they are similar triangles. So what I have here is this little triangle here I'm going to call triangle 1. This second one is going to be triangle 2, and this last one will be triangle 3. I will figure out these ratios. I'm going to move this over just a little bit. So for triangle 1, which is this triangle right here, my opposite leg is 1.47. My hypotenuse is 2.53. So sine of A is 1.47 over 2.53. And I get it equal to 0.581 when I round it to 3 decimals. Triangle 2 is going to be this pink one. I get 3.57 and 6.14 are the opposite of hypotenuse. So sine of A is 3.57 over 6.14. I get exactly the same 3-digit number I had before. And then finally, I'm going to do this big one is the orange triangle. I get my opposite side is 5. My hypotenuse is 8.6. So I get sine of A is equal to 5 over 8.6. And again, I get 0.581. So I have the same decimal, 3-digit decimal number every single time, even though I use 3 different sized triangles. And they are similar because they all have angle, angle, angle similarity. Now I want to show you what it looks like on the calculator. So what I'm going to do is, I'm going to go to my calculator. I'm going to make sure my calculator is in degree mode. So I want to type in the sine of 35, actually 0.54 degrees into the calculator. Not the 35 because this angle is actually 35.54. So the 3 keys we're going to use are these keys right above the comma and the parentheses, 2 above the number 789. These are the sine, cosine, and tangent keys. These are very important. But before I go on, I have to make sure I'm in the right mode. If you look down here, the third line down, I have something called radian mode and degree mode. Radian mode is something special that we will learn later, if not this year, Algebra 2, and it's carried on in calculus. But we want to be in degree mode. So if you're in radian mode, say if I hit enter, I'm in radian mode. So what I have to do is put my cursor over degree, hit enter, and now notice that degree is highlighted, so I'm in degree mode. I hit second mode. Mode key is right above, below the window, above the X key. And now I'm in degree mode, so now I could type in sine of 35.54. And I close my parentheses, I hit enter, and look what I get. I get basically the same number I had before, is about 0.581 when you round it to 3 decimal places. What does this mean? It basically means this ratio is always the same no matter the size of the triangle. These are similar triangles, and the ratio of the sides are always the same. I'm going to do the same thing, but this time I'm going to use the cosine ratio, which means I have to do adjacent over hypotenuse, and my adjacent side for the small triangle, the blue one, is 2.06. Hypotenuse is still 2.53. So cosine of A is 2.06 over 2.53. I get about the number 0.814. I'm going to do it for the other triangles when I turn off the video. And notice when I did it for the second triangle and the third triangle, even though I had to use different numbers, I still get the same ratio or decimal, 3-digit decimal 0.814. And I'm going to type in the calculator the cosine of 35.54 degrees and see what the calculator says. And when I go to the calculator, now I'm going to type in cosine of 35.54, and I get this number, which is really all about the same because the size of the triangle does not matter for the trig ratios. As long as it's the same angle, you're going to have the same ratio when you're done. Okay, let me go back. And I lost it. Okay. Let's go back. And where'd we go? I lost my little cursor. I'm going to freak out. It's twice, same spot. Let's try some problems. It's dealing with angle X, which is here, which means this is the opposite side, this is the adjacent side, and 50 is the hypotenuse because 1 is along the side, and second is across with a 90-degree angle. And sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when I use this, I get 40 over 50, which is 4 over 5. Please reduce. Adjacent is 30 over 50, which is 3 over 5. And tangent is opposite over adjacent, which turns out to be 4 over 3. Please reduce your fraction. Now, this gives me sine of x equals 1/3. It says draw a picture and the Pythagorean theorem. Well, here's my picture. Here's angle x. And sine is opposite over hypotenuse. So this is side 1 over side 3 because this is the opposite side and this is the hypotenuse. So right now I have 1 squared plus b squared, I'll call this side b, is equal to 3 squared by the Pythagorean theorem, or 1 plus b squared is equal to 9, or b squared is equal to 8, or b equals the square root of 8. You could just leave it as the square root of 8. And when I want to do cosine of angle x, that's adjacent over hypotenuse, and the adjacent side is square root of 8, and the hypotenuse is still 3. And finally, this last question here on this page, can cosine ever equal 2? The answer is no. I mean sine, can sine ever equal 2? Well, sine of an angle is always opposite over hypotenuse. The hypotenuse is always along the side, so it's always the larger number. Opposite side is always going to be shorter than the hypotenuse, so sine of an angle is always between 0 and 1. It can never be below 0, and it never can be bigger than 1. Okay, we have triangle FHG is similar to triangle DCE. That means they have the same angles, but different scaling. Well, let's pick a scale factor. One isn't given to me. Let's just choose one. Make it easy on ourselves and make it equal to 2. So this side is 90, this side is 56, and this side is 106 when I do my scale factor. And if I'm looking at angle H, which is here, that means this is the opposite side, this is the adjacent side, and this is the hypotenuse. So when I do sine over H, I get 90 over 106, and when we reduce it, I get 45 over 53. Cosine is adjacent over hypotenuse, which is going to be 56 over 106. When I reduce, I get 28 over 53, and tangent is opposite over adjacent, which is 90 over 56, and when I reduce it, it's 45 over 28. And then when I notice this picture, this is just the sine of angle C, this is the cosine of angle C, and this is the tangent of angle C, because scale factor did not change anything. Yes, the sides of the triangle are different, but the trig ratios are exactly the same. So when I do number 1 here, sine is opposite over hypotenuse. Here's angle Z, and opposite is going to be 21 over 35. So when I reduce it, I get sine of angle Z. I can divide by 7, I get 3 over 5. Now when I do cosine of angle X, it's adjacent over hypotenuse. I get 21 over 35. So I get cosine of angle X is also equal to 3 over 5. These are the same. That must be your reason. Second part. So now when I have cosine of Here's angle C. Cosine is adjacent over hypotenuse. I get 16 over 34. If I reduce it, I get cosine of angle C is 8 over 17. Then finally, tangent is opposite over adjacent. Angle A is here, so opposite is, I get 16 over 30. So tangent of angle A is equal 8 over 15. And basically all I'm using every single time is a special word. So, ka, toa. Okay, thank you for watching this video, and I'm sorry about the glitch in the middle that caused the video to record without me doing anything for about a minute.